Next, I want to test their efficiency claims. They claim that this inverter is greater than or equal to 91% efficient. Now, a lot of these little inverters like this are not very efficient. Some of them peak at 85%. I've seen them peak at around 70% before. The best inverters are around 95% efficient. Now, I want to see how efficient this one is and over its full range, from 100 watts-ish all the way up to its full capacity, 1200 watts or so. And I'm not going to show how I do this exactly here because I've done that in other videos, but it'll be connected up to my charger, my two fully charged batteries, running through their cables right here. I'm going to take my multimeter here, connect up directly to these terminals so that I'm not taking into account any of the cable losses, just the inverter. And I'm going to measure the current going into the inverter with this clamp meter. Volts times amps equals watts. I get my watts input. And then for the output, I'm going to use my P3 kilowatt meter, which I know is around 1% accurate. And for loads, I'm just going to use resistive loads. I have an electric heater here as a bulk load. And then I have, I think, 9 100 watt bulbs here. I can screw those in one at a time. Volts times amps in the input, that's watts. Watts output here. Compare the two and get my efficiency. So I'm going to do that and then show you the results. Here are the results of my efficiency test. I have the input amperage, the input voltage, and the output measured power. With that, we can get the efficiency. At 100 watts output, it's around 84% efficient. It peaks at around 88%, around 500 watts or so. And after that, it slips back down. At around 1000 watts, it's 83%, and once you get up closer to its 1200 watt limit, it gets below 80, but it's really not fair to include that. This is a 1000 watt inverter. They're just giving you that additional 200 watts as a bonus, and I applaud them for it. So we're really going to say that it's around 83% efficient at full load, 83% efficient at very light load, and it peaks at around 88%. Now that does fall short of their 93% or 91% claim, but really I'm not going to knock them too much for it because it is close, and really 88%-ish efficiency on an inverter in this price range at 1000 watts is pretty good. You're not going to get a whole lot better than that. So the efficiency of this inverter is pretty good. A note about fan noise in this inverter. The fan is load controlled. I don't know for sure if it's temperature controlled or not yet. I suspect no because I don't see any temperature measuring device in here. It could exist in one of those surface mount boards. I just didn't see it. Certainly is not measuring the FET or the diode temperatures. I know that for sure. It could only be measuring the internal case temp, which isn't all that useful. In any case, the fan turns on at around 300 watts, turns off below that, and that makes the inverter pretty quiet for most purposes. If you plug it into your cigarette lighter, you'll never hear the fan at all. It'll be silent. I also haven't heard it buzzing or hissing or making any other annoying noises, so it's pretty quiet, even with those loose inductor cores in there that I had shown in the first part of this video. But the fan itself, when it is running, is mid-range in its volume. It's not an annoying vacuum cleaner type fan. It's pretty reasonable, so this inverter audibly is not too bad. So the next test that I'm going to do, there's the fan noise of it, not too bad. The next test I'm going to do is a long-term stress test. I'm not going to run this thing completely full bore. I have my heater on low. It's going to be drawing 800 watts or so, which is about the most you'd realistically want to draw out of a 1000 watt inverter. And while this runs, I'm going to be monitoring it, making sure that nothing gets ridiculously hot or anything like that, make sure that everything's working properly, and so forth. Also, these cables over here, these cables are really marginal, so I'm going to keep track of that and see if the cables that they provided really are okay or not for this particular inverter. And my heater seems to be drawing about 850 watts, so we're just going to let this run at 850 watts for an extended period of time and see what happens. Now, because there's no temperature sensing on the actual FETs on either side of here, I'm pretty sure that if you ran this at 1200 watts continuously, it would outright fail. But just don't do that, and it's not going to be a problem. It's a 1000 watt inverter, treat it as such, and we'll just see how well this thing holds up. Now, I did add thermal compound to this portion of the case so that it should heatsink better than it did before. This is the input stage, which normally gets the hottest. This is the output stage. So I'm going to let this run for a while and report back to you on how it's doing. I tried turning my heater up to high. It's drawing about 1150 watts right now. It's been doing that for about 1 minute, and already these cables are too hot to hold on to, even through the insulation, and they smell really bad. So I'm going to turn my heater back down to medium because that's just not going to work. These cables are not adequate for this inverter. If you plan on using this thing heavily, I highly recommend to put your own adequate cables onto it. And depending on what happens soon after here, with this heater on a lower setting, I may have to switch the cables just to continue this review. Now, it isn't completely unreasonable for them to include these lighter duty cables, other than fire hazard reasons and the like. But ignoring that, it's not too unreasonable because a lot of times people don't even use the cables provided. They just throw them away. What a waste. So I don't blame them a whole lot for putting in these lighter duty cables. After all, they are constructed pretty well. The connections on them over here are actually pretty good. Over here, none of the connections are getting warm. It's just the wire itself that isn't adequate. So I'll let this continue running. This inverter's been running for maybe 5 minutes. The input side over here isn't very warm. The output side is quickly getting almost too hot to touch here, but we're just going to let it keep running for a while longer. The fan, unfortunately, doesn't blow a whole lot of air. The fan grate over here is just a stamped opening. It doesn't allow a whole lot of air out. They really should have done a better job on this fan opening because it doesn't move a lot of air. So it doesn't really cool the insides of this inverter very well. I would like to see something a little bit better, but I'm just going to let this run for a while and see what happens. Well, I've had this inverter running for about 20 minutes at 850 watts, so nearly full load. The cables that they gave me are still too hot to hold on to. They are not adequate for this inverter. If you plan on using heavy loads, please make your own cables that are adequate for this application. But I'm happy to say that the inverter works just fine. On the input side of it, it stays relatively cool, closer to the output side. Output meaning the airflow side. It is much warmer. It's about 45 Celsius on this side of the case. It's been holding steady, so it's not going up in temperature. I can still turn it to about 1200 watts, and it still outputs around 1200 watts, just like it did before. Now, I don't know how much my additional thermal compound helped it, but I'm comfortable in saying that even without that, it would survive this sort of full load environment. And overall, yes, it handles heavy loads quite well. So I'm happy with its continuous output performance. So the Bestek 1000W power inverter, what do I think of it and would I recommend it? Well, I've seen a lot of different inverters and this one ain't half bad. That may not be a glowing endorsement, but realistically, this inverter here is worth what it costs. It is more expensive than the cheapest crap on the market, but this is not crap. This is actually a pretty decent inverter. Sure, it has its shortcomings. Its output waveform, for example, its no load current draw, a few other things, but its construction quality is very good. It's advertised as a 1000-watt inverter, yet it does 1200 watts. That is rare. It doesn't really have any surge capability. I didn't show that testing in this video, but its surge capability really is pretty much zero in realistic circumstances, but it does have a soft start capability where the output voltage sags with increasing load, which allows you to start some heavy things. It runs my full-sized microwave oven, which takes more than 1000 watts. That's pretty impressive for a 1000-watt inverter. It's small in size. Overall, I think this is a pretty good value. So if you're in the market for a 1000-watt type inverter, and you don't need pure sine or don't want to pay for it, then this would not be a bad choice. Bestek 1000-watt inverter. I gotta say, I'm surprised and kind of impressed. This is Neuronar. Thanks for watching.